And I'm on the community team at DBT Labs. I'll be your host for today's session, announcing DBT's second language, when and why we turn to Python. You may have heard the news in yesterday's keynote that DBT is growing beyond SQL and now supports executing Python models. What? Wild, right? After many years of exclusively SQL, DBT is excited to meet our community where they are and serve its diverse use cases. We are joined here today by the product and engineering leaders behind this new development. The one and only Jeremy Cohen, or Jericho, OG product manager of DBT Core. Cody Peterson, who joined DBT Labs as a product manager just a few months ago, and who comes from Microsoft, where he spent almost 5 years in the MLOps product space. And also, Leah Antkiewicz, senior engineering manager of the core team, and the first engineering manager we've ever had at DBT Labs for the core team. With so much excitement around Python availability in DBT, it's important to understand the best applications for this feature. When is it useful to use Python, and when should you stick with SQL instead? What might a multilingual DBT project look like in practice, and what could it make possible for your team? I've been assured by the team that no snakes were injured in the development of this product. A few last notes before we jump in. All chat conversations and Q&A will take place in the Coalesce Announcing Python channel of DBT Slack. This allows us to connect with the remote attendees tuning in from around the world. If you're not part of Slack, what? Join now. Visit community.getdbt.com and search Coalesce Announcing Python and join. If you're already in, our chat champ, Gabriel Bolatiwa, already posted an icebreaker, so chime in. NOLA attendees, this is important. Please be aware that we're 30 seconds ahead of the folks watching online, so try your best to refrain from sharing any spoilers in the chat. After the session, these three celebs will join the Slack channel to answer your questions. However, you can get the questions going and start asking. So let's make some noise for Jeremy, Cody, and Leah.
All right, can you hear me? All right, thanks for being here, everybody. We're very excited to be announcing DBT's second language, Python. I'm Jeremy Cohen, a product manager for DBT Core at DBT Labs.
My name is Cody, a newer product manager at DBT Labs, working on Core.
And I'm Leah Antkiewicz, the senior engineering manager for the core team at DBT Labs.
All right, this is a slide that we showed you at the keynote yesterday. And just to remind you that we are very early in this journey. We're just at the very beginning. It's taken us this many years to develop and perfect and continue to improve the development and productionizing and testing everything experience for SQL in DBT. This is the first time we're ever doing this with Python too. So to set some expectations, we're super, super excited about this. We recognize that we're incredibly early in this journey, and we recognize the importance of not just providing you with functionality in terms of a product feature, in terms of code in DBT Core, but also opinionated guidance and recommendations to go along with it. Right? This is an exciting new thing. We want you to feel excited about knowing how and when and why you should be using it. I'll just say, looking ahead, or imagining, looking ahead, I'm excited to reflect at next year's Coalesce, at Coalesce 2023, look back and remember this moment and think about all the things that we expect to learn over the course of that year. We're still very early. But let's jump in and talk about where we are today, starting with how we got here.
So about 5 years ago, we came out and we made a post saying that DBT at this point in time wasn't going to support Python. So now we fast forward to last year's Coalesce, and we started to think about, well, is that still the case? And then we fast forward to this year when we decided to reverse our decision. So as with most things, we started with an idea. With that idea, we brought it to you all. We brought it to the community. We started GitHub discussions. We started lots of Slack threads, Zoom calls, in-person talks, we wanted to hear what you all thought and how this could best serve you. And once we got all of those ideas and all those thoughts, we then brought it back to the core team. And with the core team, Chen-Yu Lee was then our tech lead for the project. I want to shout out Chen-Yu and the rest of the core team that couldn't be here today and thank them all for their hard work here. And we started to implement this. And then from there, we decided to add a little extra help, and we brought Cody in, our resident Python data ML expert. And we worked really hard over the summer. And at the end of July, we released a beta. And I think it's the earliest beta we have ever released for DBT. And the reason we did this was we wanted to get, again, your feedback, see how you were using it. So we released one beta, then a second beta, then an RC, and then another RC. And here we are today releasing the final version of 1.3 that supports Python models.
So we talked a little bit about how we got here, a process that involved a lot of your feedback, your discussion, your comments, a lot of usability improvements and bug fixes over the last few months, which is why we did such an early beta. But again, going back to that fundamental question, why do this in the first place? So Python, a lot like SQL, is a language that millions of people use for data transformation work every single day. The problems they run into are similar to, though not identical to, the same kind of problems that analysts have been solving with SQL for a long, long time. Defining and documenting modular transformation steps, finding a way to test those transformation steps, to test data quality, to ensure that it is reliable and meets expectations. Don't get me wrong here. There is added complexity in adding a second language to DBT, just like with any new feature. But I don't see the risk here as adding complexity and fragmentation to the data stacks or the workflows of data teams at most organizations already. Because the fact is that at many, many organizations, that fragmentation already exists. That complexity already exists. It just isn't visible. It's in silos. It's in the Python notebooks and workflows and pipelines that are already running outside of DBT's DAG, even if they use DBT models as their inputs, or even worse, if they don't use DBT models as their inputs and are duplicating the logic, or even worse, defining different logic, the same transformations, the same concepts, inconsistently. We've just heard from our colleagues presenting the semantic layer, metrics in DBT, just how important it is to ensure that consistency, the same view of the data, the same definitions everywhere. It's a problem that exists at many, many organizations today, which have data science teams which do not work closely or at all with data and analytics teams. We're not going to get there tomorrow, right? We're not going to convince everybody to use DBT in the next week or even a couple of months, maybe even the next couple of years. But it's a longer journey that we are on together, much in the same way that we wanted to break down the silos that used to exist, still exist in many places, between data engineering and analytics. Right? Data engineers and analysts, it's a unification that we want to see as well for data scientists and analysts in the future. But if you're already using DBT and already using SQL very happily in DBT, there are also some things that Python is going to bring you. Right? There are places where Python shines, where it is just better than SQL. Much as it pains me to say, as someone who really, really loves SQL, there are Python packages developed over the last several years and decades of the open source PyData ecosystem, which just make certain kinds of data munging and processing really, really easy to get started with. Right? They may or may not be the right answer for production at scale for very, very large data volumes, but in terms of that rapid exploration and prototyping and just being able to do a standard processing step, because it's the way that thousands or millions of other people are already doing it, it's something that SQL can't really offer, or you're limited by, constrained by what your data platform SQL dialect can provide for you. And then there's data science, right? Work that has really never been possible in SQL, maybe some extensions on some specific data platforms, maybe not very flexible extensions, right? This is the work that, again, we think is that much more accessible to you as a person who's already working in DBT to start doing a little bit of advanced statistics, forecasting, predictive analytics, maybe even machine learning. We'll take a look a little bit later.
All right.
Why now? Why not a couple of years ago? It's, as Leah said, there wasn't really the ability to run Python in the way that we think we should be performing data transformation, which is to say in the cloud data platform. Right? We need to push all of this down to the remote execution engine where the data lives, where it can be scaled out and run reliably in production. So it is worth saying explicitly, all Python that you are writing and developing as DBT models is executed in the cloud data platform. Right? DBT is not running any of this Python for you. It is providing you with the framework to develop it, to define tests on it, to gather metadata on it. But all of that work is actually happening in the cloud data warehouse. And this innovation, this release, has really been enabled by the work that those data platforms have been doing over the last year, the last few years. Google creating better interoperability between BigQuery and Spark running in Dataproc. Snowflake with the advent of Snowpark Python, currently in public preview. And Databricks with improvements that they've been making for the experience of SQL writing analysts to be better unified with the long time power and capabilities they've had in PySpark. So these are the 3 data platforms that we prioritized for the initial launch. These are the 3 that you can use with DBT Core 1.3 today. And again, all that Python code is running in these data platforms.
So if you've managed to avoid it so far during Coalesce, this is a DBT Python model. If you're familiar with SQL models, it should look fairly familiar. We start with a .py file in the models directory. We define the required models function with the DBT and session objects. We ref or source our upstream data, and then the rest is all on you. You put your transformation code in between and return a data object that gets persisted in the data platform at the end. We want to be very clear about what DBT Python models are, as Jeremy mentioned, that this code gets shipped off and executed in the data platform, and what they are not, which is basically anything else. If you find yourself doing something outside of this intended bounds within DBT Python models, note that you are in experimental territory. We definitely want to hear about it. We want to see all the cool things you can pull off. And we recognize that Python opens a lot of doors that either weren't there in SQL or were much harder to walk through.
Yeah, I think the dirty secret here is a lot of this stuff is possible in SQL if you're willing to make it happen. But I think SQL writers tend to be, I don't know, a little happier staying inside the lines. And Python's a little more of a abstract, expressionistic, free-form, color wherever you want.
People do wild stuff.
Yeah.
I've seen a lot of it.
So in some sense, like, this is not new, right? This is not a new set of capabilities. But what's also not new is the framework. DBT as an ELT tool, the T in ELT, and we want to see the same opinions, the same guidance being followed, which is why we worked so hard on creating a consistent experience that will feel a lot like a SQL select statement returning a data frame.
Yep. So where are we today? As Jeremy mentioned, Python models are available in version 1.3 of Core, and also available in cloud. Simply select the 1.3 for the environment that you're going to use. Now, we think that SQL is better at some things and Python is better at others. At DBT, we are very big on using the right tool for the job and doing things in a sensible way. So for our demo today, we are going to try to demonstrate to you when to use SQL, when to use Python, and what a project might look like with both of them available. So without further ado,
let's have some fun.
It's demo time.
Yeah, enough talking. I think we all want to see it, right? All right, so we're going to do something fun today. Instead of just doing a demo, fun fact about myself, I've been golfing as long as I could walk. So we're going to just play some code golf. Maybe not the most common sport you've heard of, but the goal of this is we're going to have a competition between Python and SQL. The most concise, elegant, comprehensive code wins the challenge. We'll have 3 challenges. So with this, we're going to get in the character here a little bit. All right, are we ready to play? We have some competitors here today. We're going to set the scene. The scene here today, ladies and gentlemen, is we're at the first annual Snowflake Invitational. We are at the beautiful Coalesce course in New Orleans. We have two competitors here with us today. The first one is our OG SQL expert, Jeremy. He has Snowflake SQL in his bag today. And then alongside of him is our contender, Cody, our Python expert. He is going to be using Snowpark as his club of choice. So, before we get down to it, we'll be playing 3 holes. There's a little bit of fast forwarding that you'll see in these challenges. Just like regular golf, the middle gets boring. So we want to keep things moving. If you happen to miss some details that you would like to see at some point, we will have all of these demos up in a public repo for everyone to see afterwards. So if you missed anything, don't worry, it'll be out there for you all to reference later on. So, Python, SQL, are you ready to go?
I think I'm ready.
Play ball.
Play ball.
Play ball.
That's what they say.
I think they say that in golf. All right, so for challenge 1, we're going to be helping out the coffee shop at the golf course. They have a table of orders that they want to get some stats on. Stat. So what does that mean? We're going to look at getting the standard deviation, min, max. Let's summarize all the columns as well. Do you both feel good about getting an answer for that?
So I know he said SQL, but I can use DBT SQL, right?
Yeah.
Okay.
Don't worry.
Right. Yeah.
Okay, cool.
Wouldn't come to the course without it.
Yeah. All right. Ready, set, golf.
Okay.
Oop, wrong place.
Okay. Okay, so I'm gonna want to sum max of every. Okay, so it's like order total. Okay. Sum.
It looks like we might have someone done. We don't even need to fast forward here. But all right, we'll call it for right now. Let's call it. Let's look at the answers. I think since Jeremy, you're the OG, we'll let you go first. What do you have?
Okay, so I didn't get that far. Can I just I like prepared a better answer ahead of time. Do you mind? Okay, I'm just gonna.
Yeah. Go ahead.
Yeah, so this is what I was going to do if it hadn't been over in 30 seconds. So I was like, okay, I've got this orders table. Right? I know that I want to have a couple different aggregations, count, min, max, etc. This is just like me plotting out my compiled SQL that I'm going to end up with. Right? It's going to look like select, okay, count, label that in the row as the metric, the summary statistic that I'm calculating, count to the first column, count to the second column. I would use an introspective query in DBT, right, to figure out what are the columns in this table, and then it really end up drawing this up with looping over for each of these different aggregation types and summary statistics, and then for every column, maybe just the numeric columns, yeah, something to think about in this model, and then end up with some compiled code that looks a little like that. I have a worked solution here. Hopefully you don't think that this is cheating. And yeah, this is what it ends up looking like. Results, okay, pretty good. The compiled code, right, it's a lot of, okay, union all. I kind of like this, right? It's like super repetitive, super redundant. It's really easy to see what's happening, and like if there's a comma missing or too many commas, right? I can dig in and find the right line of code. This was the drier version that I wrote using DBT Jinja SQL. Actually, someone did make a DBT package that does something pretty similar, which is cool. So I could go to the DBT hub and dry up my code even a little bit more by using someone else's work. So that's
So what does debugging all of that look like?
Yeah, so I would just compile it. I would look at the compiled SQL, sort of just like go line by line. If I go to preview it, in this case it worked, but if it didn't work, right, I would find the line and then.
Looks like you're skirting through some sand traps on that one, but I'll give you a par. You got an answer, so
Yeah,
I'll say
okay.
par there.
Right.
Cody, what would you have over there for Python?
Yeah, that was a lot of code, Jeremy. Pretty simple. I defined my model function, I referenced my orders table, and I called .describe. I also cheated here and did get the full solution, adding some comments, splitting out some variables, pretty fancy stuff. But yeah, we can go and take a look at that in this analysis, SQL, and see that our results match what we expected once it loads. We get the summary, the mean, max, count, min, everything that we want across all of this data, simply using a method that's built into pretty much every Python data frame that exists.
That was it?
That was it.
Jeremy, you better start stretching. I don't think this is going to go well. I'm going to declare a birdie over here for Cody. So a win for Python on this hole. We'll see how this goes on the next hole. I'm a little worried. So. All right, challenge 2. So now we would like you to take that orders table and be able to summarize it based on the type of products purchased. So I'm thinking like product IDs across the top for columns, orders for rows. In golf, I'd call this a dog leg, but I think for non-golfers, we might be pivoting here. How do you all feel about that? Yeah?
Ready to go.
Ready? All right. Ready, set, golf. I don't know if we put that in the rules.
I have the answer on my phone here. I gotta. Whoops.
How do we feel about fast forwarding? Are we close?
Getting there.
Getting there? All right. Can you feel the tension in the room right now?
I think I've basically got it. We can fast forward at this point.
Okay, cool. Well, Cody, since you won the last hole, I think you're up first this time.
Yeah, well, let me pull up the solution. I didn't quite get there. I had to check the Pandas API very quickly. But this is what it ends up looking like. So we get our tables that we need, the orders, the products, the ordered items. We get the list of unique product IDs. And then we have this very nice looking method chaining with the Pandas data frame here. First, we're going to group by, we're going to aggregate, we're going to reset index. I don't really know what that does or when you need it, but it's important. And then you're going to pivot, and that'll get you the subtotal for each product and get you the result you're looking for.
Yeah, so it's cool you got to write the word pivot in there, but it was everything before, after, and in the middle.
Yeah, it was a little hard to get there, but you know.
We might have left the fairway and gone into the trees on this one. It's not the clearest of answers. I think I might have to declare a bogey on this one, Cody. All right?
Fair enough.
Okay. Jeremy, what do you have for us?
Yeah, so I had the basic idea pretty quickly. There was a little bit of more work just to get everything plugged together, because we actually want to be summing up order totals, but we also need to be pulling from the products table to get the valid product IDs. But really, it just looked like using this pretty straightforward dbt utils macro that lets me introspect the database and get the valid product IDs from the products table. And then I'm just doing a pretty easy loop over that, sum case when. That gives me every single subtotal column. Again, the compiled code here does look a little bit redundant, but I don't have to be writing this SQL myself. I can be templating it and making it a little more dynamic with this Jinja. The really nice thing compared to that stuff was it's just in the CT where I can also be including other grouping columns that I want at the order level, and I can actually perform other aggregations, again, at the order level that don't have to be messing with the subtotals I'm also pivoting out. So there was no need here for a self-join. I didn't even really need to mess with window functions. I just end up grouping by 5 columns at the end. This is a little bit superfluous, but just to show what's possible. I do know that there's even a pivot macro in the dbt utils package that I could have used, but I wanted to do it myself. There's a pivot function in Snowflake SQL, but it's not there in every single SQL dialect. It has kind of funky syntax, or at least syntax that I'm not used to. So this was the approach that made the most sense to me. You can really look at this and see a lot of what's happening, but without having to see in the source code stuff that's just going to be repeated over and over, even though it's pretty easy to go in and debug after.
Wow, I'm impressed there, Jeremy. I think that's a solid par from my end. So that actually gets us to the last hole in a tie, I think. So it all comes down to this. Are you two ready?
I think so.
All right. OK, challenge number 3. Back to the coffee shop. We would like to help them start to implement their rewards program. And for that, we need to be able to aggregate their regular customers' orders over time. The thing is, we kind of have a Starbucks problem on our hands. Not everybody might be the best at spelling, or they're going really fast. So I'd like to find a way that you all could be able to aggregate these customers' purchases, but be able to deal with the names being slightly different. Some may say this problem's a little fuzzy. Do you think you can handle that?
Yeah, definitely.
I love the confidence. All right, well, let's see. All right, ready, set, golf.
I think there might be a package for this one.
We might have left the golf course on this one. Golf takes 4 hours. Do you all know that?
I'm still going to cheat. How you doing over there?
Yeah, so I guess there's this edit distance function.
Yeah?
The number of...
That sounds cool.
Would your lives be easier if we fast forwarded?
Yeah, I think I have the idea that I'm gonna pursue here. Should we come back in a couple hours?
Hours? We can go to the 9th hole, have a drink, and then come back?
Yeah. You go ahead. I'll be there soon. Should we jump ahead?
Yeah, I think
Show
so.
them what we got? Okay.
I think the people want it. I think we can start with you, though, since you won the last hole. No pressure.
Oh, me? Yeah.
Yep.
Okay. I was having fun there, right? There's no amazing way in SQL to just snap your fingers and make this happen, but the right components are there depending on your data platform. A lot of SQL dialects do have this kind of base level function to compute Levenstein distance, the number of characters you need to change to get from one string to another string. There's this kind of standard way of deciding what the closest match is between a set of options and then a given string that you have by picking, it's like computing a ratio, right? It's either the fewest number of characters you need to change or the number of characters you need to change as a percentage of the longer string, right? Or the same if they're the same. It's called Levenstein ratio. okay, this is the naive approach that I'm going to pursue. Once I had that foundation in place, I'm pulling in customers. These are the actual customer names. I'm pulling in orders. Just for really quick iteration in dev, I limited this to 1,000 records, but it's actually not that much slower if I run it against the whole thing. I do have to perform a cross join here, which sometimes you need it, right? So from orders, I'm going to compare every single order to every single customer, possible name, every single candidate string, right, to find which of the strings is the closest match. You might know this as a Cartesian join or Cartesian product. Then I'm going to help Snowflake a little bit by just saying you can throw out any Levenstein ratios that are lower than 50%, because if you have to change more than half of the characters, that's really not going to be the same person. So using edit distance, I was able to, again, compute for every single customer order pair, what's the number of characters would need to be changed, what's the length of the string that's longer, calculate the Levenstein ratio, and then do a qualify window function here at the end. This is a really nice Snowflake SQL thing, if you know it, to take whichever of the matches had the highest ratio, right? So what is the best match of the ones we've got? And then if I get any orders that have no matches better than 50%, OK, I give up, right? They're not getting any rewards. So all told, it actually runs pretty quickly. We are mapping Patricia, whatever this is, to Patricia Cervantes. Yeah, I mean, actually, I'm kind of impressed with myself. The only thing that took a long time was writing the SQL.
Cody, how about you?
So writing the Python for this is pretty easy. You may have seen me simply Google fuzzy string matching in Python, and it turns out there's a package with the exact function that I need that will extract one of the names from a list of given names and give me the result, as well as the likelihood that that result is a match. I headed over to the Snowsite UI to simply prototype this. You may have a bad time if you try to prototype your Python code in dbt. So I got it working pretty quickly here. Minimal amount of cheating, just getting a sample customer name and calling this extract one function. When we head over into dbt, I simply ref all my data, ensure that this package is installed, get the list of names, and then call this dataframe.apply function, which will apply that extract one function to every single row and get me the names unfuzzed in the orders table. Something wrong?
Yo, what's this thing here on line 18? Take a sample, otherwise this can take days?
That is a little bit of a problem, I will admit. As easy as it was to prototype in Python, when I did try to run this on the entire data set, naively with pandas, it may have been on track to take 30 days? Did I win?
The conference does not take that long. OK.
Do you know why it's going to take that long?
Yeah, one of the reasons is that pandas is simply single-threaded and a bit inefficient. I was actually able to do some prototyping and experimentation locally and get that down to under 10 minutes. But it would be a bit more work to get that running in dbt. If anyone's interested in helping me after the conference optimize this fake data problem, feel free to come and chat.
So you had the naive solution in a couple minutes, and then a couple hours later, something that could...
It may have taken a few hours to develop that faster solution. But to get it up and running quickly just took a few minutes.
Yeah, and if I could venture a guess here, it's because Python is also doing this kind of implicit cross-join, right? Cartesian join product, where it has to compare every single input order to every single viable candidate customer. But it's a lot less clear that that's what's happening in your code. Whereas I had to write this really scary thing, and the person who's going to be reviewing it would see it and know it right away.
Well, it sounds like this might be a wash. You both might have some penalty strokes coming your way, but I think we'll be wrapping up the first annual Snowflake Invitational, and we'll call this a tie, it sounds like. Does that work for the both of you? Yeah?
We'll take it.
We'll take it? OK. So at this point in time, we're going to take off our golf hats and put on our DBT hats. The dad jokes just keep on coming with this. And start pivoting to talk about, instead of competing with Python and SQL and having them work against one another, how can they really work together to get the best setup for you?
Yeah, so at DBT, we believe that SQL and Python are better together. Although we spent these past few minutes going head-to-head in a challenge, having Python within your DBT DAG allows you to do more. It allows you to bring more developers from your organization into your existing DBT projects. It allows you to leverage these packages, even if they're a bit slow, but help you get prototyping quickly, in the vast Python data ecosystem. Hundreds of thousands of packages, maybe not all based on data or data transformations, but they are there for your use. And more possibilities. Jeremy alluded to the machine learning and the data science aspect, and you'll see in this DAG here that we have some of it running. So let's hop back over to our DBT Cloud project and take a look. You can see in the challenges folder here, we have the Python and SQL models that we've developed for this demo. Just like with normal models, you can DBT build or DBT run, select your Python models, and that'll go and run everything. We can look at a previous run here of the describe PY model and see that the model built in about 20 seconds, and we even have a SQL test defined on it that ran in about 1 second. You can deploy these models through jobs just as you would normally, simply selecting 1.3 in your environment. And, of course, you can build the documentation. We showed a GIF of the DAG here, there, and here it is in full. So, we can see, if we zoom in, we actually used some Python models, hidden Python models here to fuzz our customer names. Then we have SQL and Python side by side. You can see that we use the unfuzzed SQL model to build orders, since that one actually ran in a much more reasonable amount of time. And then traversing along the DAG here, we can see side by side pivots. And then these funny little pink nodes over here, clustering and forecasting, training and scoring. What are those? We can go view the documentation as normal, scroll through, and look at some of these experimental machine learning models that we have. This one is training profit models for forecasting based off of our revenue metric. In the scoring, we simply load back in those machine learning models by refing our previous model and making our predictions for the future. This is available today again in DBT Core and DBT Cloud. And switching back to the slides, we are excited to release this out to the community and see what you all accomplish with it. And the idea of bringing the analytics community that is formed around SQL into the PyData ecosystem. So please engage with us, have fun, and achieve more with Python and SQL.
So looking ahead, just a little bit. We told you right at the very start, we're at the beginning of a long journey here together. The journey maybe for all of you to start playing around with Python in DBT, if you're already using DBT, and also a journey for people who are coming from a Python background, from a data science background, to start playing with DBT and seeing if it can be a framework, a workflow that makes sense for them, that brings them all of the goodness that it has brought to many, many of you over the last several weeks or months or years or however long you've been using DBT. It's one thing to create a subfolder called experimental with some profit code in it. It's another thing to actually productionize and then keep in production machine learning models. There's an entire school of thought, movement. What would you call MLOps, Cody?
It is a way of life.
It's a way of life. Traditional ML workflows need testing, metadata, logging, environment management, lineage tracking, object storage, lots and lots of things. Not all of those things are going to be possible in a out-of-the-box or super sensible way using DBT with Snowpark or even using DBT with more established platforms like MLflow on Databricks or other cloud data platforms. But we also think like some of these tools, some of these approaches, it's interesting to think about what's possible when you have access to a cloud data warehouse or data platform backing. Right? Object management is kind of different. Logging and metadata can work differently, maybe even more like the ways that we are used to working with logging and metadata for our SQL models already. So this is a long journey. We're interested in talking about it, discussing it. You'll see there are some GitHub discussion screenshots posted here, and Cody is really going to be leading the charge on can dbt do more to encapsulate more of this MLOps workflow. At the same time, we titled this presentation announcing dbt's second language, right? In the sense of deuxième and not seconde. There are going to be more to come after, we think. Not tomorrow, not several weeks from now, maybe not even next year, though we're thinking about it. What we've realized and what the Python addition, what the functionality has really helped us come to realize is parts of dbt's framework are not tightly coupled to SQL, but actually language agnostic. Right? So documentation, metadata, testing, having a workflow where you are writing a transformation query but not thinking about the materialization logic, the boilerplate that needs to happen behind the scenes to persist it in your data warehouse or update it incrementally. We were able to very neatly, I hope, translate a lot of these concepts from SQL into Python, and we think we could do the same in the future for other languages. In addition, there are a lot of very exciting languages or like new frameworks for writing SQL or writing, let's say, lower level transformation code that are more composable, easier to unit test. We want to make it possible for people to access those other modeling languages, those other transformation languages, and still get all the benefits of dbt. So another discussion, another journey that we are just starting on is imagining, again, a multilingual dbt that goes beyond just Python or Jinja SQL, though always preserving the capabilities that you have come to know and love using SQL, using Jinja SQL inside dbt. One last thing, sorry. We're not just going to add all of these in as options and say, great, use what you like. We're not going to tell you when or why or how or provide any opinionated recommendations, right? dbt's power is as an opinionated workflow, as an opinionated transformation tool. So we want to give you these options so that when we can also say, as we have in this presentation, when we think each one shines. And when we think Python is the right tool for the job, or SQL, or some third or fourth language for modeling in the future.
All right, to close us out, kind of like Cody referred to earlier, and same with Jeremy, we can't do this without you. So we'll ask you to please try out Python models. Let us know what you think. Open up a GitHub issue, a GitHub discussion, open up a PR. We're very happy to review it. We can't do this without you and your feedback, so any help and contact from you all is greatly appreciated. And to close this out, I just want to say thank you all for coming to our talk. Thank you for being here. Thank you again to the core team that couldn't make it today, but I'm guessing watching online, so thank you all for your hard work. And I think we have time for some questions.
All right, so we'd love to take, let's see, we have a little bit of time for some questions. We have like a minute or two. Does anybody have a question here in this room, or is there a pinned question in Slack? Guillermo. Yes.
So I'm wondering how are you seeing that you're going to be able to handle the possible... Okay, sorry, repeat the question. Yep. So you did the demo in Snowpark, and I'm wondering how Snowpark evolves maybe and diverges a little bit from PySpark, which is the other two supported backends that you have right now. How are you going to manage that? And if there's going to be something like a dbt utils that tries to wrap some sort of logic on top so that you can have the same functionality?
Yeah, that is a very good question, and it is very much top of mind for me. I have some thinking on this in some of the GitHub discussions, so feel free to drop your thoughts in there. In short, though, yeah, the fragmentation between the data frame syntaxes, pandas, Snowpark, PySpark, even others that are available, is definitely a problem for the user experience on the Python side of things. And it is something that we will want to have a DBT opinion on, and does that look like a package that abstracts over them? I don't think so, but we will be providing some more thoughts on that in the open, so feel free to engage with us on that.
So the first thing I really want to try, I don't know if this is a feature that you're already thinking, but probably yes. Can we define macros in Python as functions and then call them in SQL scripts?
So that sounds like a user-defined function, a Python UDF, yep, that you could define in a Python file and then call it from SQL. That's definitely something that we're thinking about, yeah, over the next couple of months. It's sort of possible today, like in the same way that you can write any SQL you want in the data warehouse. We want to make it a more seamless experience. For now, we targeted just models pulling in data frames, returning a transformed data frame, rather than going all the way toward user-defined functions that you can access anywhere. But the support for UDFs is pretty different across different cloud data platforms. So that's something that we're going to have to be either abstracting over or documenting what's possible where.
Maybe one more? No?
Could I just ask, if it's okay, a show of hands? Has anyone here had a chance to run a Python model yet already? A couple? Okay. There is a workshop tomorrow building your first DBT Python model. No one is going to leave that workshop without having successfully run a Python model in DBT. So if your hand was not raised and you're interested in having it so, that's a great first opportunity to do it. Otherwise, there's the documentation. I think it's pretty easy to get started, and it should feel a lot like DBT.